Hello and welcome to lesson 6C. I can prove two triangles similar. In this lesson, we're going to talk about proving triangles similar in a way that we've previously talked about proving triangles congruent. We have some very similar theorems that show similarity rather than congruency in triangles. And the first is the AA tilde postulate. And if you remember, guys, back to when we did the triangle zoo activity, when we were cutting out all those triangles, there was one category, angle, 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 that produced similar but not congruent triangles. And we said at the time, this is going to come back. Don't forget it. Well, here it is. Basically, it says that if you know that two pairs of congruent corresponding angles in a pair of triangles are congruent, then you know that the two triangles are similar. Symbolically, if angle A is congruent to angle D, and angle B is congruent to angle E, then I know that my two triangles are similar. Now, in our activity, we actually had three congruent angles, but we really only need two. And this makes sense because if we know the degree measures of two angles in the triangle, we can find the third angle because all three of our angles add up to 180. So for example, in these two triangles down here, 36 and 115, is going to add to 151, and then 180 minus 151 gets me that this is a 29-degree angle, not a 28-degree angle, a 29-degree angle. So both of these angles here would be 29 degrees. So we only need two angles to know the third angle, which is why we just need this to be angle, angle, tilde. It's going to save us some time in actual formal proofs to use two angles as opposed to three. Our next similarity theorem is the side angle side similarity theorem. And this is similar, but not exactly the same as side angle side, because in this one, we say that if two pairs of sides are in proportion to each other and the angle between them is congruent, then ABC is congruent to DEF. So what that means is that side AB and side DE, they're not congruent, but they're in the same ratio as side AC and side DF, and that the angle between them would be congruent. Guys, I'm using dots as opposed to tick marks because those sides are not congruent, but they are similar. There isn't a universal sign for similar sides. I use dots just because it helps me track what's going on. So let's look at an example of this. And this down here, I'm going to see if 18 over 24 is in the same ratio as 27 over 36. 18 over 24 is a common factor of 6, so this becomes 3 over 4. 27 over 36 has a common factor of 9, and it also becomes 3 over 4. So yes, those two sides are in proportion. And then both of these have 32 degrees as their measure. So yes, these are similar by SAS tilde. All right, and let's look at the next one down here. My last theorem is the side-side-side similarity theorem, and it's the one that you've been using without even realizing it. When we taught you how to prove two shapes similar, we taught you to look at the ratio of all of the sides. This is that just formalized. It's saying that side AB over side DE is in the same ratio as BC over EF, which is in the same ratio as AC over DF. It's what you've been doing before. So take a minute now in MML and go through and tell me, are the following triangles similar? And if they are, why? Hopefully you got your Edpuzzle questions right. If you didn't, go talk to your teacher. All right, let's take a look now at some formal proofs of these things. So in this problem, I'm given that EF is parallel to HI. So I've got EF parallel to HI, and I want to prove that my triangles are similar. Well, whenever I have parallel lines, I often have alternate interior angles that I can mark congruent. And when I look at this guy, I've got two pairs of alternate interior angles. So I can actually prove him similar by angle, angle, tilde. I like similarity proofs. They're usually a little bit easier than congruency proofs. So let's go ahead and do this formally. So just like before, I set up with my statement and my reason. EF is parallel to HI because it's given. And now I'm going to talk about the angles I've marked on my diagram here. I can say that angle E is congruent to angle H. Why did I make that step 5? You know what, guys? there's not enough coffee in the world some morning. Let's try this again. Step 2, angle E is congruent to angle H, and my reason is the alternate interior angle theorem converse, because we've got parallel lines and a transversal. Step 3, I can do angle F is congruent to angle I, and my reason is the exact same reason as before. So I'm going to use my little quotation marks for each word to show that I'm quoting the previous line. The alternate interior angle theorem converse. And now for step 4, I've got two angles proof congruent. Therefore, I can say triangle EFG is similar to, not congruent to, triangle HIG. And my reason is AA tilde. Now, I know some of you guys are sitting here going, but you could have done this another way, Miss Rob. You could have marked the vertical angle instead. Yes, I could have. That's another way to do this proof. I just chose to go about it by doing the alternate interior angles instead. Both are correct. It would not matter which one you chose. All right, guys, let's look at a slightly harder proof now. This proof, I'm given that I've got some perpendicular sides here. I know that JM is perpendicular to KJ, which would be this angle here. NM is perpendicular to JM, that's this angle here. And then I'm given that I've got two sides in ratio with each other. I've given that JK over NM is equal to JL over MO, which means looking at this, I can do some work to show that my right angles are congruent and that my triangles are going to be similar by SAS tilde. That's how I prove them similar, but I'm not asked to stop there. I'm asked to prove that this triangle is isosceles, POL. And an isosceles triangle requires that these two little segments be congruent, or that these two angles right here be congruent. And so that's going to be my goal for this proof. If I can actually prove that the larger right triangles are similar, that means that all of their corresponding angles are going to be equal. And if their corresponding angles are equal, that means these little angles here, angle NOM and angle KLJ, are going to be congruent, which will force POL to be an isosceles triangle. So that's where we're going to go with this proof. So let's go ahead and set it up. So my first step is just to talk about all my givens. Now we're going to deal with those right angles. So I can say in step 2 that angle J and angle M are right angles, because in step 2 we were given that we had perpendicular sides. So it's the definition of perpendicular. Notice again, just like always, I'm lining up my symbols here so that we've got carryover from the previous step. All right, so now we can say that angle J is congruent to angle M because all right angles are congruent. And at this point, I've got congruent angles, I've got two sides in proportion, I'm ready to prove my triangle's similar. So I can say in step 4 that triangle KJL is similar to triangle NML, and my reason why they're similar is the SAS tilde, side angle side similarity theorem. And now I can do the cool stuff. Now I can say that because I've got these similar triangles, I can say angle POL is congruent to angle PLO. Those are my little tiny marked angles down here. Because angles in similar triangles are congruent, right? Those are two angles in the larger triangles. And therefore, triangle POL is isosceles. And we learned this back in Unit 4, guys. Triangle POL is isosceles by the converse of the isosceles triangle theorem. Basically, that says that if you've got a pair of congruent base angles, then you have an isosceles triangle. And we're done. Excellent job, guys. Take a look at the MML assignment for this, and y'all have a great day. Thank you.